Hi, everyone. Hello, and welcome to today's webinar, How Inspectors Are Using Elios 3's 3D Models in the Field. Today, we're going to have a special focus on FlyAware and Inspector 4.0. We're so excited to have you all here today. I just have a few housekeeping items to go over, and then we're going to dive right into the presentation. So thanks so much for coming. We're really excited to get started. So here at the beginning, it's important to say who we're going to have speaking. My name is Zach Dukowitz. I'm the Senior Communications Manager here at Flyability, so I'll be your moderator today. I'll also be presenting in the webinar, talking about use cases, showing how 3D models are being used by inspectors in the field. With us as well, we have Adrian Brio, our co-founder and CTO here at Flyability, and we also have Charles Ray, Global Field Operations Manager at Flyability. A quick note, we often get asked, are you recording the session? Yes, we are. If you'd like to view the recording, you'll be getting it via email by tomorrow morning, your time, wherever that might be. So just know that if you miss something or if you'd like to share this with a colleague, we are recording and we will be sharing the recording afterward. We also encourage you to ask questions. So you'll see there's a questions pane. You can type a question in at any point. If we don't get to your question in real time when you write it, we'll be saving a lot of questions for a Q&A at the end. So please feel free to dive in and ask questions. So just a quick rundown of the agenda, and then we're going to pass things on to Charles, who will be presenting first. So the first 5 minutes of the webinar will be the introduction. That's what we're doing right now. Charles will be presenting on how to make 3D models with FlyAware and Inspector 4.0 using the Elios 3, of course. That'll go for 15 minutes. After Charles presents, we'll pass things to Adrian, who's going to be presenting on 3D model accuracy, FlyAware versus GeoSLAM Connect. The accuracy you can see between the two options. That'll take 15 minutes, and then I'll be closing us out with a presentation on Elios 3 3D model use cases from the field, showing you how both FlyAware and GeoSLAM are being used by inspectors. My presentation will also be 15 minutes, and then we'll have a Q&A of 15 minutes at the end. And I want to say, if you get through the presentations and you can't stay for the Q&A, you can of course view that later in the recording. So please see this, as your presentation. Get what you need out of it. We're just so glad to have you here. So yeah, without further ado, I'm going to go ahead and get things started with Charles. Charles is going to join now to talk about how to make 3D models with FlyAware and Inspector 4.0. So Charles, if you'll join us.
Cool. Thank you very much, Zach, for the introduction and everything. The subject is a little bit how to use the data from the drone, the data that you can collect during the flights, so in live and the live map, and also the post-processing of the data and what do you do with those data. So you can go to the next slide. Yes, cool, thank you. So the important step for inspection is, the first step is to prepare your inspection, make sure that you have a clear objective, that you have done your risk assessment, that Elios is the right tool for the job. Then also in the preparation, if you want to get the best out of your inspection, is really to decompose your flight and know exactly what you will inspect in each flight. By doing that, it's gonna be way, way easier to do your report at the end and to gather the right data and as quickly as possible. Then, of course, in the first step, you also have the preparation of the material, which is important. Then on the second step is really performing the inspection. So basically the flights. You will try to follow as much as possible your flight plan that you did in the first part of the preparation, just to make sure that you will cover all your inspection points during your inspection. Then also, when you're in the field, you will always be able to check your data, so the quality of the data, and also to check if you have covered every point of your inspection at this time. And the third step is the post-processing. So where you can download your data, review your flight, create your inspection report, and later on, if needed, create your model in GeoSLAM. Zach, please, next slide. So this is gonna be a video done during a training in Stewart. And we'll see how the trainee here, after 1 day of inspection, started to use the different live view.
And Charles, just a reminder, when I hit play the video, it'll automatically mute you. So if you want to talk over, just make sure to unmute yourself.
Yes, thank you. So here the journey is flying in a sewer. The idea is to see a little bit what are the possibilities with the drone and the control that you have on the live map. So you will see he will be flying backward a little. Well, on the way back. There is some contact a little bit with walls. That's why the drone is wobbling a little bit. And then he will make the camera, the live map bigger. So he will change it. So still in flight. Should be done in a couple of seconds now. The camera is lagging on my side, Zach, but okay, here he's changing with the live map view. So in here you can see that the arrow, it's a drone. If you zoom enough, you see the drone exactly and where the drone is aiming at the camera. So tilting up, tilting down. You can use the map to really move around to make sure you understand where is way back. You can see the trajectory. And you also have the two red dots behind of the drone are the point of interest that the pilot took during the flight. So point of interest are useful when you see something good, something bad, some point of inspection. We like to take point of interest during the flight. That will help us to create the report after. At the end, also, I guess that I missed on my side, you could see the piloting slicing the video. So slicing the top of the map. So when you fly on multiple levels or in a sewer like that, slicing the top or the bottom of the map will help you to be able to follow the trajectory. So even when you fly in an extremely dusty area, you can follow your trajectory and you will be able to come back almost all the time without any issue. Next slide, please, Zach. So by the end of the day of inspection, what we always recommend is to check that everything was recorded properly on the drone. And to do that, you use Inspector, you connect the drone to your computer, and you get to this page that will show you that you are uploading, you are streaming the video, the data that are stored on the drone. Next slide, please. So in here, you can see all the flights that are recorded on the drone. So that's where we can see that it's important to name the mission or the inspection that you are doing and name each flight. So you make sure that you have everything recorded on the drone. If you do 1 or 2 flights in the day, it maybe doesn't matter. But if you do 20 flights, it's going to be much easier to process your data after if you had renamed them properly. And you will also see if there were any bug or issue in the recording of the data or anything, you will be able to see it here. It will tell you if the data are not properly stored. Next slide, please. So now you are back at the office. You have downloaded all your flight on Inspector. You open Inspector, get to this page where you have all your recent flights. And you can directly see if you were flying an Elios 2, an Elios 3. You can see if you had the LiDAR on the drone, if you had a map that was created. And that's one vision of what you have recently opened on the drone. If you go to the next slide, Zach, you will find the inspection section of the inspector. And that's where you can see your flights stored by the name of the inspection. So AM Kazakhstan was a stack inspection that I did recently. I could see that here I did only 1 flight, but the flight after, called mine in Semi, I did 2 flights in this area. And that's where you can see with the title, they are stored together. And you will be able to really see everything that you did during your day of inspection or the time you did your inspection. When you want to open one of those flights, you just simply click on it. And that will lead us to the next slide, which is going to be a video. I recorded the video this morning as I thought that maybe the sound would be difficult. I just hope that I will be able to see the video at the same time without too much lag.
Charles, I'm going to go ahead and press play.
So now you are in the first page of your inspection. So you have the name of the inspection that you can change if you did a mistake or if you want to rename it. The name of the flight, if you want to rename this flight to, this is going to be important for your inspection report. A view of the preview of the map and the point of interest that you took during the flight. By pressing on open, you get to the inspection flight. So you can see that it already started to play. So we'll pause it. And on the right side, you have the camera of the drone. And on the left side, you have the map that have been created during our flights. So here you can, of course, move around your map with the mouse of your computer, or you can have different view on the top left here. We'll take a top view, and here we're gonna zoom a little bit inside, and we're gonna play the video so we can see the different view that you can have of your data. So here you have an independent view of the map. You can also choose in here if you want to have the camera around the drone, so that can help you to understand where the drone was flying, and you can see it synchronized with the camera. Or you can choose to be the drone itself. So that's the same thing. You can really see where the drone was moving in the asset. For the video, we will really use the independent vision, but then you have the shading. You can have the original shading, circle, contour. Very often we use the transparent shading. This allows us to see really where the drone is flying. You can increase the point size and the point opacity. Then when you move around, another tool that can be very useful is the map slicing that you can also do here. It can really help you to understand where the drone was at. And you can also, by doing that, extract nice footage that you will be able to put in your report after. So you can slide from beneath and from over it to really have a good vision of what you are doing. Then here, we will have some tools at the top here, and that's the measurement tool. It will allow you to take measurements on the point cloud directly. So in here, I will use this old OR pass, and just by selecting 2 points, I will be able to do measurements in meter directly on the map. I can also play with the view of the map to make sure that I select the good point, or use the slicing again to make sure that I really select one point at one elevation, or just to remove some points so I can really see what I'm measuring. The second tool on the right of this one will be the measurement of a surface, of a polygon. So here I'm slicing the map so we can really see it directly in it, in the blueprint, in the point cloud. And I can select 3 points, and I can see it in square meters. I can have those measurements staying on the model by clicking on the small saving button on the right at the top of the screen, or I can remove them with the trash bin. So then I'm putting back the map in there. And the next step that can be very, very useful to make sure that you see correctly your video will be to play the video quicker or faster. So you can play the video up to 5 times the normal speed, or slow it down to 25% of the normal speed. That can be quite useful when you are looking for one specific frame, and the frame that shows the most what you are looking for, and best frame that you could add in your report. In here, the small green thing is the point of interest that I have taken during the flight. So you can see that I took one of the kind of OR paths that was a bit blocked, and one of the stope. No, not the stope, sorry, the OR path. Because when I was flying, I saw something that I thought that was not supposed to be here. So I just took it when I was flying in front of it, because that was my recall flight. And I thought, by doing this point of interest at this point, I will remember that there is something interesting to see there. It would really give me a time frame of when it was. So then in my inspector, I will orient my camera view and my point cloud view correctly, and then I will play the video at slower pace, or I can use a keyboard of the arrows of the keyboard to go frame by frame to be able to see an interesting point. When I found an interesting point, I can create a new point cloud, no, a POI, sorry, and I can put an annotation directly on the picture. So here I could see some fuses that were left in the rocks. So I put the annotation here, and in the annotation tool here, you can rename your point of interest. You can put a comment and a criticality level. It's also possible to add some tag specific to your use cases and your industry. Then to help also the inspector later on to remember where it was, you can add a 3D view of the point cloud to really be able to show where the problem was. And by slicing the map or orienting it differently, you can really understand where was the important point. So here I'm adding one. I will slice a little bit the map to try to really isolate the area so I can see even better where the drone was oriented and where are those fuses. And I can add multiple views of those of this map, play with the opacity of the model to really be able to show to the inspector where it was. Also, because potentially, if that's really important for the inspectors, I will be able to find those areas very, very quickly next time I fly in this area. And I'm also playing the video again after, because I could see that there is another cable fuse there. So I can add a second point of interest, doing exactly the same thing, putting some different camera angles, putting some annotation in this point POI. And in here, I can also add another, so renaming them, add some comments, and in the comments, but that it's maybe something to inspect in the next inspection, with again view from the 2-point POIs that I have done. So you can also see from the other fuse that was left in the rock, where are the next one, if it's exactly over it or if it's on the side of it. That's going to be very important information for the inspector or the future pilot that will redo the flight in the future or right after. So here I'm taking another image where I try to overlay the two point of interest, so I can really see where it was in the overpass. And actually, in an inspection, you spend more time creating your report than flying the drone to make sure that it's well documented and that you get the interesting information straight out of the post-processing of your flight. So here I'm also displaying another thing. I'm changing the coloration of the map by time. And I will be, with that, able to see how the drone actually scanned the area. So here, with the small hand and the blue line, you can really change by time when you were taking the data, capturing the data. And in some cases, like this one potentially, as in this overpass, I had to fly up and down again after. Maybe taking a picture or a live a 3D view of this area would actually be better in terms of understanding where are the problem, because the point cloud will be less dense. So you could also achieve that with the opacity or the point size. But in some case, if you flew quickly or you had to fly faster back, you could have some small double features and double walls that you will be able to remove by doing this time slicing. Then you also have a mapping feature with data map that was available on Elios 2 already. So if you fly without the LiDAR, and in the integration page, you have the ability to extract picture, to do Pix4D models, or the GeoSLAM export, so you can post-process your image in GeoSLAM. So at the end of all that, after your notation, you just click on create an inspection report. You rename it, you save it wherever you need to. You can choose between a Word format or a PDF. We recommend the Word just because then you can continue to work on your report. And in a couple of seconds, it will appear at the top left here, and you can just open your report. And here you have a Word document with the date of the inspection, the name of the mission, your POI. So if you don't rename it and you make no notation, it looks like that. If you rename them, you can see here, it's not written POI2, but maybe unblasted fuse with different points. The annotation are on the pictures, the description, the criticality, and those kind of information. So it actually allows you to create your report very fast, depending on how many inspection points do you have, but it gives you an output very, very quickly compared to doing print screen and copy pictures in your folder, in your Word document. So then the next subject would be really the accuracy and GeoSLAM versus FlyAware, because the accuracy is always important. And it's gonna be Adrien that will present this part.
Thank you so much, Charles. And yeah, Adrian, I'll go ahead and hand it off to you to discuss accuracy.
Excellent. Thank you so much, Charles, and thanks to everyone attending. And it's really exciting to see all the interest in 3D modeling. And while today the webinar is mostly about FlyAware, which is our SLAM engine, it's very relevant to still speak about the possibility to further process with GeoSLAM Connect. And I'll share the differences, since that's often also an important question. I'll let you go to the next slide, Zach. So yeah, FlyAware is really the SLAM engine inside cockpit and inspector, and you saw examples of both of these applications, which really come out of the box with an Elios 3. And then GeoSLAM Connect is an option for those who want to really focus on the 3D model and its accuracy. GeoSLAM is a company which is now acquired by Faro, which is really a leader in terms of processing LiDAR data to generate survey grade models with all sorts of features that are also very relevant for some industries. On the next table, there are a few explanations on the differences, and really you'll understand that FlyAware and GeoSLAM Connect are very complementary. So first of all, FlyAware is really processed on Elios 3 in real time, and it's an algorithm focused on robustness in most conditions. There's no capture guideline. It's really meant to work to localize your drone or localize your data in any inspection flight. And yeah, the software features that Charles described are around really helping the live inspection or doing reporting on typically visual inspections. And so the use case is really when localizing the drone or the inspection data matters. And GeoSLAM Connect is only a post-processing software. It actually is not real time. It takes quite a few more minutes than the capture time to do the processing of the data, because the SLAM algorithm is really focused on high accuracy, and there are capture guidelines that can optimize the accuracy when you fly in an environment that you want to map accurately. And really, there are many software features around surveying, like georeferencing, that will come out soon, or merging point clouds to build a larger digital twin, doing more advanced floor plans, volume measurements. And so in general, when the 3D model really matters for your application, when that's one of the key deliverables. GeoSLAM Connect may be relevant for you. And so one of the questions we get a lot, which I will address now, is what is the difference in terms of accuracy between the 3D models that you get with one or the other software? So that's on next slide, where actually that's the question indeed, and I'll share on next slide already the methodology. So you may have followed already a previous webinar where we shared actually a characterization of only the GeoSLAM models that we get on Elios 3. So we used that same data set. There is an article that you can find on our website if you want the full extent of the study on characterizing the accuracy of GeoSLAM models. And on the same data set, we actually looked at the accuracy of the FlyAware model. For those who are not familiar with this article, we surveyed a large underground area with terrestrial LiDAR, Rigel, terrestrial LiDAR, and it took 6 hours to actually do all the scans and merge them. There were 15 targets placed all over the environment as sort of points that we could use to compare in terms of measurements or localization. And on the next slide, you will see the trajectory of the drone in that asset. Typically, while it took 6 hours for the terrestrial LiDAR, it took one flight of 8.5 minutes for Elios 3 to go through this 70 by 50 meter underground area. We followed the capture guidelines to obtain highly accurate models, like typically going sideways through door openings, doing some 360 turns from time to time, closing the loop also. And each scan, we went and did 3 flights actually to have a sort of significant amount of data to compare. And each flight was then processed by FlyAware and GeoSLAM Connect. And so that gave us 6 scans, which were then compared to the ground truth from the Rigel station, which we assume is sort of perfect, which is not exactly true. You may also know that reflective targets are adding a little bit of noise in the capture. So there is some extra noise that comes from other factors than the inaccuracy of GeoSLAM or FlyAware, but it still provides a very interesting comparison. So you can see on the next slide just the capture in fast forward by Elios 3 through that asset, just to give you a sense of how it looked like. I think Zach, you will play the video. And if not, yeah, we will.
There we go.
Okay.
Sorry, Adrian. It just took a moment.
No worries.
Just a reminder that you're muted when the video starts.
True, yeah. Thanks for that. And you can see it's fast forward. Although it gives you an idea of the type of environment, you can see many rooms, lots of doors to cross, lots of, let's say, rooms with stuff in them, like pipes or tanks, also quite some empty spaces. And well, after 8.5 minutes, the scanning is done. And so then we went and selected various distances between targets, which we measured both on the ground truth from the Rigel total station. If you can show again the presentation, Zach. And we measured these distances between targets also on the GeoSLAM scans and on the FlyAware scans. And we could, on the next slide, please, Zach, show that the average error of the distance measurements on FlyAware were of 18 centimeter, while on the GeoSLAM models, they were of 3.5 centimeters. So, you know, while the FlyAware model remains very good whenever you want to show where the data is. If you really need precise measurements, you can see you can get a really significant improvement by further processing with GeoSLAM. And the other thing we did on the next slide is we simulated a situation where we can georeference the 3D model only around takeoff location, assuming all of the rest of the asset is has no ground control point because it's out of reach. And so there's really this colored section of the point cloud that is used for aligning with the ground truth, with the Rigel scan. And then we compared the error of each target location in the FlyAware scans and the GeoSLAM scans versus the Rigel scan. And that allowed us to get a notion of drift. Drift is how much error there is after the distance that is traveled. And the further the distance, the more error accumulates actually with the mobile mapping that we achieve with FlyAware and GeoSLAM, and the bigger the drift. And so here with FlyAware, we could have an average 1.4% drift, which means typically the targets all the way on the bottom left are about 100 meters away from the takeoff point. And that means the models show them 1.5 meter in average wrong. Whereas with GeoSLAM, the drift is 0.2%, which corresponds to a 20 centimeter error at 100 meter distance. So this is approximately a 7x improvement with the GeoSLAM post-processing. There is a sort of visualization of what that error looks like on the next slide, where you can see on the left the GeoSLAM model versus the ground truth. The ground truth being in green, the GeoSLAM model in white. And you can see they match for the most part. And on the right, you can see that the drift is much more visible with the FlyAware model in yellow versus the Rigel ground truth in green. And definitely here, that's only the XY drift, which is probably around less than 10 centimeter on the GeoSLAM scan, which you barely see. Actually, in this case, it even looks slightly less. Whereas with the FlyAware scan, you can definitely notice it. So again, that's when you have maybe long distances to travel, and if really the georeferencing and the accuracy of the 3D model you want to extract matters, that you can get a significant improvement by going with the GeoSLAM post-processing after your flights. And so that's for the rough explanation. We'll release an article with this information as well, and maybe a few more visuals. And yeah, that you know should help you choose between yes or no. I need to do some further processing with GeoSLAM and purchase that package, or I can really focus with FlyAware on reporting, doing reports and localizing data. On to you, Zach. Thanks.
Great. Thank you so very much. I appreciate it, Adrian. So give me just one moment and I will dive into my presentation. So we've heard about how to use FlyAware and Inspector 4.0 to create 3D models from Charles. We've heard about the accuracy you can get from the 3D models you get with FlyAware and Inspector 4.0 compared to the accuracy with GeoSLAM Connect from Adrian. So I'm going to talk about how people are actually using these two options in the field. I think it's always important when we talk about features and technology to then tie it back to actual use cases. We see sometimes people getting very excited about LiDAR, 3D models, but I think it's always important to say this is how inspectors are actually doing the work. So that's going to be what I'm covering in my section. So to start things off, I just want to highlight some of the main benefits and uses that people are seeing, and then we're going to look at some actual case studies. So one of the benefits you get from having a live 3D map made as the drone flies is if the environment is incredibly dusty and blocking your camera so that you're even visually blind, you can still see well enough so that you can actually fly. So flying in dusty environments is a really big benefit. Ensuring full coverage is another big benefit. Because you can see the path the drone took through an asset, you can make sure that you've gotten full coverage for your inspection. And I'll get into that a little bit more during one of the case studies. Localizing inspection data is also a big benefit, so you can actually see where a POI or a defect that you wanted to note while you're doing an inspection is located. That's a big benefit that inspectors are seeing. Enhanced situational awareness, so just knowing where the drone is within an asset, knowing how far away you are, maybe from a manhole or some exit point. And then also improving knowledge of unknown places. So if you have, let's say, an old mine that's doesn't have a map and you want to know how deep it is or how far back it goes, how safe it might be, you can create a quick 3D map, right, using FlyAware and get a sense for the layout and what things look like. Of course, that applies to any scenario where you don't quite know what you're entering. You can send in the E3, create a quick 3D model and see what it is that you're walking into. So now I'm going to go over 4 different use cases, 2 highlighting FlyAware and 2 highlighting GeoSLAM. The first one, we're going to look at flying in a dusty environment. So this was a mission that took place at a cement plant inside of a clinker silo. So clinker is a material used to create cement. It's incredibly dusty, and you can see on the screen here, we have the FlyAware live 3D map made big so that we can see where the drone is. And the visual is basically blind because it's so dusty. The alternative to using a drone, by the way, the traditional approach to measure the volume of clinker in this environment was for someone from the plant to climb 25 meters or 80 feet into the air, stand on this unstable platform and poke a hole down into the material and sort of guesstimate how much might be there. So the end outcome here, by the way, I should mention, was to use GeoSLAM to do a volume measurement, but the FlyAware capabilities of creating a 3D live map made it possible to get that data. So that's worth noting. So the benefits that we're seeing in this case study, dusty flying is a big one, right? Thus, being able to fly in a dusty environment made it possible to get the data that was needed to create that volume measurement. Also safety, no one had to climb up on that platform. And then speed, it only took 10 minutes, just one flight to get the data that was needed. I want to highlight how dusty it was, so I'm going to show everyone a video real quick. So give me just one moment. So you can see here again, the 3D map that's being created in real time as the drone flies is really the only way that the pilot can navigate the silo. Down at the bottom, it's so dusty that the drone is almost blind. You can imagine using this for mines or really any other scenario where you have a very dusty environment. Maybe it's a storage environment, maybe other aggregates, so that you can still operate the drone even when you can't see. Okay, that's enough of that. Let's move on to the next case study. Give me just one moment to switch back to my slides. Here we go. So the second case study where we're looking at the benefits of FlyAware are using the live 3D map and FlyAware and Inspector 4.0 to ensure full coverage. So this was a oil and gas case study. It was a cargo tank inspection, and these are massive tanks. They, I think, could be as high as 30, 40 meters, so 80 plus feet. And they're also quite long. So to inspect a tank like this with a drone like the Elios 2 and make sure you got full coverage, we've heard about inspectors still needing to physically enter the tank, enter the confined space, and watch the drone to make sure it gets full coverage, which isn't ideal, right? You have this remote visual data collection tool that should make it so that the inspector doesn't have to go into the confined space so that the safety is better. But because you need to make sure you got full coverage, inspectors are still going in. Using FlyAware, you don't have to do that anymore. So the inspector can stay safely outside and know they're getting full coverage because they have a 3D map that shows the path the drone took. And it can even be used to meet rigorous inspection standards. So in this particular case study, there was a standard, or at least there was a requirement that full coverage could be demonstrated, and the Elios 3 and FlyAware was able to demonstrate that full coverage was achieved and keep that inspector safe. And it's worth noting the traditional approach. So these huge tanks, the only other way to inspect them if you're going to do it manually would be to go inside with scaffolding, and there's only one point of entry. It's quite small, so to just get the scaffolding materials inside is very labor intensive. You build all the scaffolding, it could take 15 people working for an entire day just to put the scaffolding up. And because the environment's so large and hard to work in and dark, sometimes a little bit of the scaffolding material might be left behind, which can lead to problems in the tank over time. So the benefits that we saw from using the Elios 3 for this cargo tank inspection, savings were a big one. Oh, actually, that's a mistake in my slide. I apologize. That should say full coverage. So the 3D live map guaranteed full coverage, right? That's the big benefit that we've been talking about. Safety, no one had to go into the tank. And then speed and labor, as I mentioned, it would take 15 people working for a full day just to erect the scaffolding. Then you have to do the inspection, then you have to take it down. Using the drone, they were able to get all the data they needed with just 2 or 3 people because they could just fly inside and collect the data. Okay, so now those 2 case studies really looked at the big benefits of FlyAware and how people are using FlyAware and with the Elios 3 in the field. The next 2 case studies, we're going to look at GeoSLAM and how people are using those kinds of 3D models in the field. So the first one, the country of Luxembourg has these old slate mines, and they're converting them into museums, but they're so old, there's not reliable maps that show the layout, and they also just don't really know if it's safe to go into them. So one of these slate mines, they use the Elios 3 to fly inside and collect all the LiDAR data needed to create a robust 3D map, make determinations about stability, how far the ceiling was from the surface of the Earth, how safe it might be to go inside. The traditional approach for this would be to use a handheld LiDAR scanner or some other robotic solution, but a flying robot that's carrying a LiDAR sensor really is the best solution. You don't have to endanger a person holding a handheld scanner. A ground-based solution would probably not go very far given the environment. So having the Elios 3 fly through and create 3D maps that could be used to make accurate determinations for measurements using GeoSLAM really was a game changer for this planning effort. Benefits that Luxembourg saw, so the speed, the LiDAR data was collected much faster than it could have been otherwise. Safety, no one had to go into these unknown areas within the old mine. And then 3D maps, the 3D maps themselves were a huge benefit. Just to have this record of what was there in the mine was very important for the effort. Finally, we have another mining operation. They had a hang up and an ore pass, and they worked for 2 months trying to determine, what's causing this hang up, and they still couldn't figure it out. So even though they were drilling these exploratory holes and putting like a snake camera through, and then even putting dynamite, putting blasts into these holes to try to blow this hang up loose, they still couldn't figure out what was going on. They ultimately ended up just moving on and changing production to somewhere else. When we visited, though, we flew the Elios 3 up there, and very quickly we could see what you see on the screen. The hang up was caused by this single huge boulder, and that's why some of the blasting attempts didn't work. So traditional approach I already described. Let's move on. But yeah, the big benefit here with GeoSLAM was to really visualize in an accurate way the location of the hang up, its nature, how big the boulder was, and that data could be used to make a really accurate plan for how to remove that hang up. So big benefits that we're seeing here: savings from avoiding prolonged downtimes of the operation and resulting in loss of production. Safety, I heard in the mining operation I won't name, but people would kind of lean out to look up and see if they could determine what was causing the hang up, which obviously isn't that safe, but sometimes you do what you have to do to try to move forward with your work. And then speed, it took only 10 minutes again for the Elios 3 to fly up there and see what was going on, and then to collect the data needed to be processed into a 3D map showing in more detail what was happening with the hang up. versus 2 months of efforts that ultimately didn't solve the problem. So that's it for my section. We'll be moving on to the Q&A now. Charles and Adrian, if you guys can join me. Hey guys. So yeah, let's go ahead and dive in. We're going to take about 15 minutes to do a Q&A. Yeah, so let's start with a question from Samuel. What's the difficulty of seeing any discontinuity, for example, a crack or a pore when using the Elios 3 to check process pipes? Is that something you guys could address?
Not sure exactly to understand the question.
I think he's just wondering about the level of detail you can get and really with the visual data.
Adrien, any idea?
Sure. I think detecting crack is definitely where you'll want to use the RGB camera, and it's definitely higher resolution than the LiDAR when you do close-up inspection. Especially cracks are probably more visible visually, and so the sort of optimal distance from the wall to capture the most details is about 20 centimeter. That's where you'll get a ground sampling distance of about 0.2 millimeter per pixel. So it doesn't mean you won't see a crack that's smaller than 0.2 millimeter, since you'll still see contrast, especially if it's quite dark on maybe a clearer surface. But if you want to even measure the width of a crack, you can know that you have that resolution that can help you. And then if you want to measure the length of the crack, so we have a 2D measurement feature as well, which was not the topic of Charles' presentation. But if you're facing a wall and on a single image you see the full crack, you can use a tool to do a 2D measurement where we use a distance sensor to convert the pixel sizes into millimeters. And if not, you can probably quite well use inspector like Charles demonstrated to take a POI, a point of interest at the beginning of the crack, then fly to the end of the crack, and then on the 3D model, for example, measure the length of that crack. Hope that helps and that addresses your question. And then, Charles, you have something to add?
To add something, also to see where it really starts, your crack, where it finished, we are using the side lighting to really be able to have oblique lighting to really see where it's really start by playing with the shades. So that would also help you to really see where it starts and where it ends potentially. And that could help by taking the POI, as Diane said, to use your point cloud to measure the distance and the size of it, the length of it, sorry.
Very helpful. Thank you both. I really appreciate it. Question from Catherine, who asks, how is the data downloaded from the drone to be used in other software, if at all?
So it will depend which data you are talking about. So the drone is recording .move for the video file, and you have the live map in LAS, and you have the bag file and the JSON that you can use in GeoSLAM to post-process your data. And you end up with a LAZ or different formats that you can then use in other software like Deskwise, Bentley, and those kind of softwares.
Excellent, thank you, Charles. Chris asks, how is the imaging in low light situations? Like if you can speak to, working in low light.
So Elios 3 have 10,000 lumens on it, so it's very powerful. So when you are close to any object, it will look like even if you were outside in the sun, same kind of lighting. And in very large environments, you can always force the exposure to the maximum. That will allow you to see very far into like large scope area like that. The LiDAR scanner allows you to see points up to 40 and 50 meters. So that will also help you to understand where you are in the asset.
Thanks, Charles. And Chris was also asking about the capture rate per battery. So with a single battery, really how much can you capture? And he gives a little context. He says, I'm looking to capture tank data on ships, including around I-beams, and I'm wondering what kind of volume I can scan per battery.
Do you want to answer, Adrien, or I do?
Yeah, I'll take that one then. So I would say capturing a scan, if it's really about building the 3D model, I would claim most tanks will be fine in one battery, so less than 9 minutes. Now, if the question is about close-up visual inspection, where even you would like to cover systematically the tank at a certain resolution, maybe say 1 millimeter per pixel, and you would want to remain 50 centimeter, for example, from any surface, that could take definitely tens of batteries. That's a use case that several of our customers do, and then that's where also the coverage check that Zach mentioned is very useful, since it can take definitely lots and lots of batteries to do such a visual coverage. But for really, you know, the environment that I presented was 50 meter by 70 meter with lots of rooms, and so we covered probably more than 500 meter of travel with the drone in less than 9 minutes. Even a large tank with very few rooms, probably it's just one large space, is quite a lot easier to cover. And I doubt, yeah, it will be so much bigger than 50 by 70 meter.
Thank you very much, Adrian. So David is asking about calibrating the instrumentation. Is it does the LiDAR sensor need to be calibrated? Are we able to guarantee a sort of precision that can be verifiable? Yeah, I guess that's the question.
Yeah. So when you select a mapping flight before flight, you have a sort of button to say, oh, I'm going to do a mapping flight. It's going to actually wait for 15 seconds just before takeoff, and that's really what is used for calibration, and then allowing GeoSLAM to do a better job at doing the 3D model. And then, however, in terms of guaranteeing a precision, it's really environment dependent, capture dependent, and it's definitely something that's very hard to do. And actually, the numbers I showed before on the test site, underground test sites, are really definitely only going to be true for that data set. Definitely, if it's more confined or symmetric, or if there are less features, more or less dust, more or less reflectivity, if the capture is done in a way where the drone flies really fast, doesn't go through doorways in the proper way, the accuracy might suffer in different ways. So it's hard to guarantee. So we provide these numbers as a good baseline, a good guideline, but for sure, there are also some knowledge to acquire in order to be comfortable with analyzing the results, right, that you get. There are techniques where you can use ground control points also to double check the accuracy by, for example, using some for geo-referencing and using some of the ground control points as test points, etc. Yeah.
Thanks, Adrian. And David, he has a follow-up question based on what you're saying. He said this means that you do a zero calibration point, but he's wondering, is the drone supplied with a calibration certificate for the instruments that are installed for the LiDAR sensor?
No, there's no calibration certificate, and I'm not sure I understood the part about the calibration points. If these are targets that you would put in the environment that you can georeference, very soon GeoSLAM will release the features where you can automatically extract the targets and match them to known locations and give you an error value about how the matching worked out, and that can give a good insight as how much you can trust the accuracy. Maybe that answers part of the question. Yeah. But remember, it's a mobile mapping solution, huh? So it's definitely not the same grade that you can obtain with a terrestrial LiDAR. That's for sure very important to understand. There's no way. We're talking about centimetric precision, while the terrestrial LiDARs typically are in the millimetric.
That's really helpful. Thank you, Adrian. James is asking, can you complete multiple scans and combine the data in GeoSLAM for a single model? And if you can't, can we recommend another software solution that could?
Yeah, so the answer is yes, you can on GeoSLAM Connect. And even very soon, if you have targets in these models, which are scanned by in the two scans, it will even automatically align. While today you need to do a little bit of manual course alignment before there's a refined automatic alignment.
Excellent, thank you.
There's and you know, the value also with this feature on GeoSLAM is that they have handheld scanners that can also complete your models, which you can mount on vehicles, which you can carry handheld through a plant, for example. In some cases, it might be complementary to use handheld and Elios 3 scanners.
Got it. Thank you very much. Sylvain is asking, is it possible to use POIs as ground control points to register the point cloud with a previous topographic survey?
It's a good idea. At the moment, no. I would say it would require that we have a feature where you can really position the drone very accurately in the same location over and over again for this to make sense, but or to have some automatic extraction of some visual targets that are then fed. But at the moment, no, it's not part of the features. But point taken.
Got it. Okay, thank you. Let's see. Carlos is asking, what kind of training would a drone pilot need to have before doing the kind of inspection flight that Charles, you were showing when you were presenting?
So the first one in the sewer was done by a trainee after 1 day of training. So with the drone comes 1 day of training. It can be done on our simulator on the tablet and the remote control, or in person. And that will really teach you how to use the drone, what are the good practices and everything. If you are completely new into the world of the drones and the drone inspection, we recommend the AIM training, aerial indoor inspection methodology training, that will last for 2 days, in which you will really learn how to prepare the 4 different kinds of inspection possible, how to do it, how to post-process them correctly. And in this training, we find real assets. And after that, you should be good to go. It will always depend, obviously, of your inspection type. If it's really, really hard inspection or easy one, some might need a little bit more practice. But for basic one, after 1 day of training, we are able to make people fly in those environments without any issue.
And I will add that ease of use was really at the foundation of the Elios 3 project. And you know, we put so much technology on Elios 3. It's the most advanced indoor drone where you have an onboard computer fusing data from this very powerful LiDAR, these 3 cameras, really to make it easy for pilots to fly in these tough indoor environments. The drone being always stable, you having always this situational awareness with the live map. It's the drone that we designed from the ground up to be in everyone's hands, and to sort of also demystify indoor inspection, which can seem daunting at first, and even though we've been for now more than 7 years out there with products, it still seems sometimes a bit crazy to fly inside plants, inside mines, but for sure Elios 3 makes it easy.
Thanks so much, Adrian. We have a question from Roderick. Is GeoSLAM the only way to produce volumetric measurements with the LiDAR data you can get with the Elios 3, or can FlyAware also create volumetric measurements?
No, for the complete processing, if you want to have a high accuracy map, you should go from, you do your flight, you post-process your flight into GeoSLAM Connect, and then you can use other software to do volumetric measurements. If the accuracy is not very important, you can use potentially the live map. We did it in small stockpile, and the results were not too bad, but it's not done in FlyAware, it's done in other software like Cloud Compare or other software like that.
Got it. Thank you very much, Charles. Ravi is asking a question. So Ravi uses FARO software, Scene for point clouds. Given the acquisition, FARO has purchased GeoSLAM, as you mentioned, Adrian. Ravi's wondering, can he still use Scene to process the data, or would GeoSLAM also be required? I don't know if this is still in transition, but if you could speak to the possibility of using other software in the FARO portfolio, if that might be possible. If there is an answer, yeah, just curious.
Yeah, I think the FARO acquisition of GeoSLAM is extremely exciting because it will definitely open new opportunities. There's not more I can say right now, but definitely there's some opportunities that should follow from this year. But I don't have information yet that I can share.
Okay, thank you very much. We're coming up to the end of our time, I just want to say, so I think we'll do one or two more questions. If we don't get your question answered live here, I just want to say this is really the beginning of a dialogue, so please reach out. You can see both Charles and Adrian have their emails up here. We do want to make sure everyone gets everything addressed that you'd like to get addressed, so if we don't get to your question live, please do be in touch. That being said, let's do one more question from Ian, who's asking what accuracies can be achieved in areas so no control targets can be installed. Does that question make sense to you guys? I'm not sure if that's...
Yeah, so I would say one way to georeference your model is to match it with another model you may have georeference, or sometimes you just don't need any georeferencing, but just to merge models. And so that's actually what we did for one part of our test, where we took the takeoff area and matched it with ICP to the ground truth. Here, however, there's again many factors that can impact the accuracy, and I wouldn't be able to say yeah how you could yeah guarantee what accuracy you would get with such techniques, because it will depend really on the matching algorithm and the other model that you match it to, and maybe the question was about something different, but yeah, I don't have much else to add.
I appreciate it. Thank you. Let's do one last question. So a few people have asked about this. Pavlos and also Franco, who's here, are asking about storing 3D live maps so that you can refer to them later. So Pavlos, the question they asked was, can mapping be stored as history to have it readily available for future inspections, like to facilitate minimum flying time, so you can use that past model as a reference? Is that something you guys can address?
So in any case, today the maps are stored on your computer as soon as you download them from the drone. However, I think it's a very good question, and because it's definitely allowing me to speak a little bit about our next steps and the roadmap, where indeed it's only the beginning in terms of how we want to use these 3D models and the data. Today, there is indeed always one 3D model per flight, but it's only natural that we move on to merging everything into a single one, even over time as you repeat inspections, and even as indeed you use maybe another drone even, but you could already have the 3D model preloaded. And so all these are features that we're working on. However, at the moment, you'll always start a new map, let's say, when you start a new flight. That's what happens for now.
Got it. I think that's going to be our last question for today. I want to thank Charles and Adrian so much for being here. Thank you everyone who tuned in for the webinar. I hope it was useful. As I said a moment ago, if you didn't get your question answered today live, please reach out, use the emails that you see on this slide in front of you. We hope to be in touch. Yeah, thanks so much everyone, and that's going to be it for today.
Thanks everyone. Bye-bye.
Thank you. Have a nice day.